Perfect.
Okay, perfect. Right. So yes, this was the introduction. So I'm basically going to present one of the papers in my PhD, and it's about the interdependency between countries through moisture recycling, particularly between forest and agriculture. And so this is the paper that just got published in Nature Water some weeks ago, end of October. But first, I want to talk about why. So why do we study this? And first of all, it is mainly due to like the fact that we have like increasing understanding on moisture recycling process and the importance of land. So there are like a lot of studies that also we talked about in this network on extreme events and the role of moisture recycling in extreme events, on forests, for example. And the question is then, so what? Or like, and then what? And so I think we wanted to try to imagine like, given this importance of moisture recycling and land, how can we actually imagine the management and governance of moisture recycling because of their importance? And I think we wanted to use a lens that is like a little bit more policy oriented, and also kind of like studying moisture recycling, not in isolation, but like as part of a bigger conversation on different aspects of our society. So I think this is when kind of like this gap between the scientific call to kind of think about forests beyond carbon. So there are like a lot of some scientific papers on the importance of forests and that we have to start thinking about forests as an important kind of ecosystem for maintaining climate and other things through moisture recycling. And this has been highlighted by different organizations. But at the same time, there's also really like very rigorous pledges, policy, and monitoring systems actually to conserve forests. So this is where we think about forest, kind of like the gap between the science, but also kind of the implementation side. And that's when we chose to have, focus on like this moisture agriculture interdependency as a lens. So kind of forests and agriculture, they're like connected through many different processes, not only through moisture recycling. And they are also connected at very different scales. But in this particular study, we want to kind of like increase our understanding on the role of precipitation. So like how much precipitation is applied by forests that falls on agriculture, and in the kind of the opposite direction, how agriculture kind of like affects forest. And that is kind of like the inspiration of the idea of it. So then the objective of the study or the paper is actually to study the dependence of crop production and export on precipitation from upwind forest within and across countries. And we wanted to kind of establish this global interconnection between countries through moisture and crop. But then we want to think about forest and agriculture being kind of remote from each other, as in we want to focus more on like the regional to global scale, and see where that leads us. So the methods that we did was basically we first kind of established a global map of areas dominated by forest and agriculture. So this is like a spatially distributed maps of kind of like forests being located remotely from agriculture. And when I say remote, it seems like, oh, it's kind of far away, but it's just like at a different scale. And then we kind of established the moisture flows from this forest to agriculture. So forest as a source and agriculture as a sink, spatially distributed and across countries. And then we assess that against the crop water requirements. And then lastly, we pair these moisture flows with crop production and crop trade. So the first step, kind of like I'm just gonna go quite briefly on the method, but like the first part is like harmonizing MODIS as like a land use classification data set with MIRCA and SPAM, which is kind of like a cropland data set that has or that can be linked to an agricultural production and yield as well. And then what we did was actually we replaced the cropland and the mosaic cropland in MODIS with physically cropped areas in MIRCA and SPAM to attribute for the crop production later. And we end up with this map that you see. So like the green one is forest dominated and the purple one is agriculture dominated. And the result of this kind of data harmonization is quite representative of like the forest and the agriculture worldwide. So as you see, like it represents 94% of the total forest areas in MODIS. And in terms of agriculture, it's above 80% of the original data set. So either MIRCA or M3 or SPEM. And in the second step, we actually try to kind of like this establish spatially distributed moisture flows based on already kind of like available source to sink moisture flow data set by Utrecht using ERA 5. And then we aggregate that into countries. And then the third step, we actually assess kind of like this moisture flow or like basically rainfall that is originated from forest and agriculture against the crop water requirements that is modeled by the Watnitz model that also differs between green water and blue water fed system, agricultural system in this case. And the last step is actually to pair that moisture flows as well with the crop production and the crop trade flows. So I think the kind of the most tedious part of this step is actually to harmonize the crop classes between the 4 different kind of like crop or agricultural data sets. Based on like the crop code of FAO. So as you see, like each data set has different classes, but they all can be linked back to FAO. And so I'm going into the results now. So the first kind of like spatially distributed results is that what we found is that forest and agricultural dominated areas globally are kind of well connected. So if you see the green one or the forest dominated area and the purple one or the agriculture dominated area, and the gradient of the color is kind of like the level of dependence on moisture from upwind region. And so I want to point out on the kind of like the dark purple area, which is the agricultural area that is like highest dependent with the highest dependence on evaporating forest. And the green one is actually evapotranspiration. Sorry about that. So yeah, so if I point into the like dark purple areas, 50% of these dark purple areas globally actually have their crop water requirements fulfilled. In as we studied it, and so that means like the agricultural dominated area that is highly dependent on upwind forest could have their crop water requirements fulfilled by just the amount of precipitation. And if we look at kind of like the difference between how much the extratropical forest supplies as compared to the tropical forest, I don't want to go into so much details here, but I just want to show that since we also model it for kind of like a monthly fluctuation, there is kind of like a different timing between when a certain crop, so for example, like here, wheat is grown in the growing areas in the purple lines throughout the year with the amount of kind of like precipitation that comes from forests. So in the case of wheat is like from the extratropical forest throughout the year, kind of like there is like a supply of moisture, but maybe that is what is stark is, for example, here maize. So when kind of like the maize is like grown much in the world, let's say with the high growing areas, it coincides with kind of like the moisture that is supplied by upwind forest. And between the green and the blue, the difference is between green water fed agricultural system and blue water fed agricultural system. I'm just going to continue. And in the study, we also kind of propose typologies of the interconnections between countries through moisture and crop. But like the first two is actually just based on moisture, let's say. So like if a forested country supplies moisture to itself while also producing crop, and the same case when it kind of like supplies moisture to another country that produces crop. And the last kind of like three typologies is like more referring to the combination between moisture and crop flow. So for example, a forested country supplies moisture to downwind, like another country that produces crop, but that downwind country actually exports crop back to the forested country. So this is the circular kind of like interdependency. And in this case, where the second from the last one is like a forested country supplies to another country to produce crop that then exports to a third country. And by now you have figured out how to read this, but like I'm just gonna say, so the last one is basically a forested country producing its own crop, but then exporting to another country. And just to look at like the first two typologies, for example, how moisture is related to like crop production and export. So here is divided by column, like national recycled moisture, and on the right side, transboundary moisture. And then the top one is more crop production, and the lower one is crop export. Just want to highlight here, like, for example, I'm going to point at this dark gray here of Brazil, dark gray there, and then the dark gray of Argentina on the right. So basically, Brazil and Argentina are both big global crop producer and exporters, but depend on forest differently, because Brazil depends more on the national kind of like moisture, national forest, whereas Argentina actually depends highly on transboundary moisture from other countries. In this case, Brazil actually mainly. And then so there's also kind of like the dependency between like countries like Ukraine, Romania, Paraguay, and Uruguay, who are actually important exporters, but depend mainly on transboundary moisture. And when we kind of like look at the three lower typologies here and then like combine it together, you can see in this graph actually like how this interdependency between countries through moisture and crops are. So basically agricultural areas in 155 countries depend on forest in other countries, whereas like 105 countries depend on the national forest. But if you see like, so the left country is the forested country, the middle one is the crop producer, and then the right one is the crop importer. So the crop producer export to crop importer. But when I look at like just the forested country on the left, so the DRC, Central African Republic, Bolivia, Brazil, Peru, Canada, and Russia, and I look at like all the countries that they supply moisture to, they actually support like around 18% of global crop production and 30% of the export that is accounted in this study. So that is what is shown by this graph. But then if we kind of like zoom in to these different kind of typologies, we can see like, for example, I'm gonna focus first on the circular flow, in this case here, Brazil. So you can see like Brazil and supplies moisture to Argentina in green, but Brazil actually imports crop from Argentina. So this is like in relative measure of the annual precipitation on the green side and of the annual import on the orange side. And so you can see like Brazil has this circular interdependency with Argentina, Paraguay, and Uruguay, meaning that it kind of like offers opportunity for like cooperation if they kind of acknowledge the dependency between each other. In that Brazil would kind of maintain their forest for the kind of like suitable or like viable climatic conditions for Argentina, Paraguay, and Uruguay while they're exporting back to Brazil. And the second from the last, so it's like a cascade across countries. So you can see, for example, Russia supplying to Kazakhstan, who is then exporting a lot of actually crops to the surrounding countries of Kazakhstan. And in this case, like for example, Uzbekistan, Tajikistan, Kyrgyzstan, they highly depend on the crop that is exported from Kazakhstan. And lastly, I want to point out on Democratic Republic of Congo here, that is kind of like nationally recycling moisture within its country, but then it's also exporting to kind of Rwanda and Central African Republic. But then in this case in Africa, I mean also in Latin America, but what I'm showing here in Africa is that these flows are a little bit more nested with each other. And so it's nice that Rafaela was mentioning about this FAO report because we were just in time to kind of like provide the results as part of the report. So again, going back to why we were doing this, at the end, we're glad that it could also actually feed into kind of a document that is not academic and hopefully might be used in the future for policy relevant discourses. Yeah, so if you want to check it out, please. And lastly, I think just to kind of like continue this forest agriculture interdependency lens, this is what I'm doing next actually, which is I'm in the next part of my PhD, I'm looking at also moisture recycling through the forest agriculture interdependence lens, but also social ecological system lens, where I look at moisture recycling as embedded in a much larger system and much complex system of shifting cultivation in the DRC. And for this research, I use actually like mixed methods combining qualitative interviews, remote sensing analysis, and moisture recycling analysis. But yeah, here I want to show you like the moisture recycling part is just like this tiny part in the right corner of the huge system with the combinations of ecological and social processes. So I guess that sums up my presentation. Thank you so much for your attention.